Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, so today also I took a new lesson regarding AT chapter 27 flight control, and this is lesson number 5. Alright, so in this lesson I'm going to talk about the flight control laws. Okay, so I mean the control law presentation. So in this lesson I'm going to talk about this uh, lesson. So if you still not watch my the previous videos regarding 88 chapter 27 general lesson series, so please watch from lesson 1 to until this lesson. It will be helpful for you. And also, if you still not subscribed to Aviation Engineering YouTube channel, please subscribe and please share these videos with your friends, relatives, and anyone who like to learn about aircraft maintenance. All right, so now let's go to the lesson. Alright, so this is the lesson 80 chapter 27 flight controls general, lesson number 5 control law presentation. Alright, okay, so let's go to the overview. In this lesson you will get the basic understanding of the flight control laws. Alright, basic understand of the basic flight control laws. Alright, so you can see the picture over there, the pitch altitude protections and load factor protections and bank angle protections over there, and the ground laws, flight laws, flare laws, ground laws again, and then high speed protections and stall protection. So I will discuss about these things in this lesson. Right, okay, so now let's go to the lesson content. In lesson content I will discuss in number 1 as normal laws, number 2 law reconfiguration, and number 3 alternate laws, and number 4 direct laws, and number 5 mechanical backup. Okay, all right, so now let's go to the first one, normal laws. Okay, you can see the basic principle over there is here is the side stick, and is go to the aircraft flight control computer, and here inside have aircraft objective, and then the surface order computations, and then it's go to the surface detection, and then the aircraft response, and then the feedback will go to the flight control computer again. Alright, so let's see the normal law. In normal conditions, the normal laws are used to compute the surface deflection orders. Okay, in normal law provides a full flight envelope protection. Remember, in normal law provide a full flight envelope protection. All right, okay, so now you can see here the ground laws, flight laws, flare laws, and again ground laws. Okay, here is ground mode, flight mode, flare mode, and again ground mode. Okay, so there are three principal control of modes. Okay, there are three principal control modes. The first one is ground mode, and second one is flight mode, and next one is flare mode. Okay, all right, you can see here the ground mode, flight mode, flare mode. Okay, so during the ground modes a direct relationship exists between the stick, elevators, and roll control surfaces. Also, the rudder is mechanically controlled by the pedals, and the yaw damper function is available. Okay, and the ground mode is activated. Right, ground mode is activated after the flare mode. Remember, ground mode again activated after the flare mode when the main landing gear shock absorber, it is not absorber, right, it should be shock absorbers, are compressed with pitch altitude confirmations. Okay, just remember it. Okay, now let's you can see this picture right here. Right, so in flight mode, right, in flight mode, here is the flight law, here is the flight mode. Right, in flight mode the normal laws, are NZ law. NZ law means here the load factor protection for the pitch control, including load factor protection, and lateral normal law, here lateral normal law for the lateral control. It means the roll plus yaw, it means like a bank angle protection, including bank angle protection. And next one, high speed protection. High speed, it means VMO, pitch altitude, theta, here is theta protection, and the stall angle of attack. Okay, angle of attack protections. Right, in flight mode is activated after the ground mode when the main landing gear shock absorbers are extended with pitch altitude confirmation. Remember, the flight mode will be activated after the ground mode when the main landing gear shock absorbers are extended with pitch altitude confirmation. Alright. Okay, now you can see in here, right, here in normal lows in flare mode. Now it's in flare modes. Okay, before I talk about the flight mode, and now in flare modes, flare low in place of NZ low, in place of NZ low, load factor protections, right, for the pitch control to allow convectional flare, lateral normal lows and stall protection, right? It's like NZ low for the pitch control to allow convectional flare, lateral normal lows and stall protection, angle of protection. Okay, so the flare mode is activated after the flight mode below a certain altitude. Remember, flare mode is activated after the flight mode below a certain altitude. Okay, right. So now let's go to the second one, low reconfiguration. You can see they have two lows, pitch and lateral. Pitch in here, normal lows, you can see the alternate low, it goes to alternate low, or else it's go to the direct lows, right? So here the crew actions and ident of the fails, ADROID, IR. So this is there's a mechanical backup. And the lateral, you can see the normal low is go to the roll direct, failures, and then mechanical backup. Alright, so configuration of lows in pitch axis and in lateral axis, right? Configuration of lows in pitch axis and in lateral axis, right? Pitch axis and lateral axis. So control loss reconfiguration are divided into two families. Okay, one is alternate and second one is direct. So there is no loss of normal low after a single failure. Remember, there is no loss of normal low after a single failure. The transfer from the normal to alternate low is automatic and depends on the number and the nature of the failure. Alright. Okay, you can see the alternate low with reduced protections. Okay, here the alternate lows are automatically introduced as soon as the normal lows are lost. Remember, alternate lows are automatically introduced as soon as the normal lows are lost. In this I talk about the alternate low, right? So alternate lows provides the pitch axis. Remember, the alternate lows provides for the pitch axis load factor protection, right? Alternate lows provide for the pitch axis load factor protection and high and low speed stability, alternate high speed protection, and the alternate high angle of attack protection. Okay, here you can see in the pitch axis they are not provided theta protections, and the lateral normal low, right, bank angle protections they will not provide. So the roll axis in direct low, the roll axis in the pitch axis in the alternate low, and then the roll axis in the direct low. Okay, right, you can see the alternate lows without protection, right? Alternate lows without protection, the high and low speed stability are lost. Remember, alternate lows without protection, the high and low speed stability are lost. Only the load factor limitation is provided. Without protection, only the load factor protection is provided in alternate mode. Okay, right, now is the direct low. You can see the direct lows are automatically activated on the ground, right? Direct lows are automatically activated on the ground. So the direct lows can be activated in flight following failures if the normal and the alternate lows can no longer be performed. Okay, just remember it. Direct low, right? You can see the basic principle over there, right? So pitch from the side stick is go to the pitch or lateral. In the here's the computer, is the surface direction orders kinematic, right? So then it's go to the elevator deflections or elevator and spoiler deflections. Then it comes to the aircraft response, right? In here the mechanical links is come here, and it's go to the rudder deflections and then go to the aircraft response. Okay, your damper orders equal F yaw rate and configuration. Okay, the direct relationship between the side stick and the surface are used. In here, the direct law, the direct relationship between the side stick and the surface are used. Sorry. Sorry. In direct law, all the protections are lost. Remember, in direct law, in alternate law and normal law, they have protections. But in direct law, all the protections are lost. Okay, just remember. Alright, so now the last one is mechanical backup. Okay, So the mechanical backup permits the aircraft to be controlled during a temporary complete loss of electrical power of flight control computers. Okay, so the longitudinal control is achieved using the trim wheel. Longitudinal control is achieved using the trim wheels, as the elevators are kept at zero deflection. So the lateral control is achieved from the pedals. Remember, the lateral control is achieved from the pedals. Okay, this is the basic principle. Okay, in this the side sticks are not available, right? So the lateral control is achieved from the pedals, and the longitudinal control is achieved using the trim wheels. Okay, longitudinal is using trim wheels through the THS. Trim wheels as an elevator are kept at zero deflection. Elevator, we have to keep it at zero deflection. All right. Okay, that is the end of this lesson. I think thank you for participating in this lesson, and this is the fifth lesson, 80 chapter 27. So the next lesson you will going to learn about the side stick operation system and priority indications. That is also important. So if you still not watched the previous videos regarding 80 chapter 27 general, I will put the link in the playlist in my description, so you can watch from the lesson 1 until this lesson, and then you will have a good idea about 80 chapter 27, because this series have so many lessons, especially from the chapter wise. I still finished a few chapters, only the general part, and I have to do so many lessons. So in future I will upload one by one, so this channel will helpful for you to do level 3 A320 family type level 3 type training full idea. And if you study these videos, and if you watch these videos, then if you're going to do the type training, is very easy for you, and you will have a good knowledge. All right, so thank you again for participating in this lesson, and if you still not subscribed to Aviation Engineering, please subscribe, please share, and with your social media platforms, and also with your friends, relatives, and anyone who like to learn about aircraft maintenance. All right, so we will meet on next lesson. Have a good day for all of you.